Hi friends, good afternoon to one and all. First of all, I would like to introduce myself. This is J. Mahendra from TTWREIS Boys, Narsapur, Medak district. I am pursuing second MPC. Today, I have a great honor that in front of you to share my thoughts and views and ideas which would happen on my topic. Okay friends, maybe you all have been aware the words like electricity and magnetism. Yeah, first of all, let's see what is meant by electricity. Yeah, flowing of anything in a conductor is known as current, or flowing of electric charges is that what we call as electric current. Yeah, electricity and magnetism are considered separate and unrelated phenomena for a long time. But in the mid-19th century, scientists like Ørsted and Ampere, they found that moving electric charges will produce electric field. They found that moving electric charges will produce electric field. Most of the questions arises like that, how this converse effect will possible? Does the nature permits us this relationship between electricity and magnetism? How does it will happen? Let's see. But the answer is resounding yes. Scientists like Michael Faraday and Joseph Henry, they did around 1817 experiments and demonstrably conclusively know that they stated this electricity and magnetism are related phenomena. Some of the two experiments which we are going to see now. So before that, the phenomena in which electric current is generated by wiring magnetic fields is known as electromagnetic induction. Hope you friends, you all have been understood what my today's session's topic is. Yeah, electromagnetic induction. So let's see a quick review of our scientist Michael Faraday. Yeah. From the year between 1791 to 1867, he was a great British physicist and chemist also, and he was a great experimental scientist. His contributions to early electricity includes like invention of motor, generator and transformer, and also law of electrolysis. So let's see about Joseph Henry. From year between 1797 to 1878, he was the first director of the Smithsonian, and he was the first to produce the Academy of Natural Science. Also, he was first to produce an electric current with a magnetic field, and he discovered the concept of self-inductance. So see friends, what is the history of this electromagnetic induction? How, if you want to move forward in our day forward, we need to grasp what was happened previously. So let's see what is the history of electromagnetic induction. Around 200 years ago, Michael Faraday looked for evidence that magnetic field would induce electric current with the apparatus. So in his apparatus, he taken one galvanometer, and that galvanometer connected to the coil, and a bar magnet was taken at a rest position. So in his experiment, he found that when bar magnet bring towards the coil, or if you insert the coil a bar magnet, a deflection will be shown by the galvanometer in positive directions. That means current is such up in the positive direction. So in second experiment, in second situation, he pulled away a bar magnet behind the coil. So in this situation, the galvanometer shows deflection, but now this time in opposite direction. The current is induced in opposite direction. And in third situation, when a bar magnet kept at rest position, does we observe any deflection, friends? No, because there is no flow of a magnetic field that do not possible to induce an current. So he found evidence when the magnet was studied. He found no evidence when the magnet was studied, but did see a current induced when the magnet moves up and down, because there is a relationship between this bar magnet and electromagnetic induction. So that's what we call, this is the history of electromagnetic induction. Let's see what is mean by electromagnetic induction. Yeah, let's see friends, and take a look on the slide. Electromagnetic induction is the production of voltage or electromotive force due to a change in the magnetic flux or magnetic field. So this is as we all know what does mean by electromagnetic induction. So let's see friends, what are the experiment which was done by our scientist. In Michael Faraday, in his experiment, first experiment, he taken a galvanometer, and that sensitive galvanometer connected to the coil, and here he taken a bar magnet through the polarity of north and south pole direction. So let's see how this will happen. So from this configuration we can see that when a bar magnet along the north pole direction, if we will bring bar magnet towards the coil C1, does we observe any deflection in the galvanometer, friends? Yeah, sure, absolutely. Definitely a galvanometer shows a deflection in the galvanometer. That means an induced current is such up in the coil C1. And let's imagine another situation when bar magnet pulled away from the coil. Do we observe any deflections? Yeah, here also deflections will be shown by galvanometer, but now this time in opposite direction the current is produced. And also imagine another situation when bar magnet kept at held rest position. Here do we observe any deflections? No, because the flow of electromagnetic fields is not possible. That's why the galvanometer shows 0 readings. So from this experiment, Faraday conclusively known that the relation or relative motion between the bar magnet and the coil is the responsible for the generation of electricity. So in second experiment, he replaced a bar magnet with the coil Q, or we can say coil Q is connected with a battery. So let's see how does it happen. So in this configuration we can see that here also we have to imagine same situation in first experiment as we done now. When coil P bring towards the coil Q, a current will be induced in the coil Q because the galvanometer shows the deflection. So the induced current is such up in the coil Q. And also imagine when coil P pulled away from the bar from this galvanometer, do we observe any deflections? Yeah, absolutely. Here, but in this time we will observe deflection in opposite direction. That means current is such up in the coil in opposite direction. And also coil towards itself also produce a relative motion between the bar magnet and magnetic field. So from these two experiments, he is known that the relative motion between the bar magnet and the coil is responsible for the generation of electricity. So if you want to find the direction of magnetic flux, let's know about Lenz Law. Hope you friends, you all have been aware what is meant by Lenz Law. See, in this configuration we can see what is the direction of induced EMF and current about Lenz Law. So Lenz Law emails states observe that the direction of an EMF has defined a relation to change of magnetic field that produces it. He gave us one simple following rule is that the direction of the current induced in a conductor when by a changing magnetic field is such that magnetic field creates an induced electromotive force opposite in the initial magnetic field. So this is what we in first experiment when we see when bar magnet pulled away from the coil, this galvanometer shows deflection, but in opposite direction the current is such up in the coil. That's what we know as Lenz Law. Let's see friends, the cause that produces an electric current in the changing flux linking the coil. Therefore, the direction of the induced current will be such that its own magnetic field opposes change in magnetic flux to the that produces the induced current. That means the induced current on its conductor or coil will be in opposite direction of the original flux direction. So this is about what we know the direction of Lenz Law. Let's see friends another situation. From this experiment, Faraday conclusively know that 4 important points. The galvanometer shows deflection whenever the relative motion between the bar magnet and the coil, and the galvanometer shows and the deflection was more when the relative motion was faster and the deflection was less when the relative motion was slower. And if you change the deflection shown by galvanometer, if you change the polarity of the bar magnet. So these are the 4 key points which he was drawn from his experiment. Hope you friends, you all have been understood. There is a interrelationship between this electricity and magnetism which was done by experiments or scientists. So how this electromagnetic concept will be applicable in our day-to-day life? Can you friends? Yeah, there are a lot of applications and there are a lot of key ideas of electromagnetic induction in our day-to-day life we'll use. Let us see friends. Before that, let's discuss about eddy currents. As we all know that eddy current is defined as current induced in a thick conductor when the conductor is placed in a changing magnetic field. Consider, for example, a conductor placed in a continuously changing magnetic field due to the continuous changing of the magnetic flux linked with the conductor induces a current will be set up in the body of the conductor by itself. This currents assumes a circular path and their direction is determined by using Lenz law. So what is the applications? Let's see applications of eddy currents. This eddy currents is applicable in high speed trains which you are using today traditionally, and in roller coaster, and for braking for smooth functioning, and in high speed vehicles or passengers. And eddy currents brakes are best substitutes for the ordinary brakes which are being used in nowadays in roadways, and every person's because of their free jerks operations. So let's see what are the applications in our day-to-day life of electromagnetic induction. So applications of electromagnetic induction includes in microphones, in tape recording and playback, and generations which are of electricity from mechanical energy. So before let's see in AC generator how this principle will applicable. Actually AC generators use Faraday's law to produce rotation and thus convert electrical and magnetical energy into rotational kinetic energy, and this idea can be used in all kinds of motors which are being used nowadays in each and every motors or vehicles. So see, an AC generator is an electrical generator that converts mechanical energy into electrical energy, as we all know that, and AC generator works on the principle of electromagnetic induction only. So this is about AC generator. And let's see electromotor. Electromagnetic induction can create an electrical motor by passing a current through a set of electromagnets mounted on a rotating shaft. So if we want to dig water from bore well, it is possible in that motor the principle is underlying is only known as electromagnetic induction only. Without this the electric motor won't be applicable or won't be run. So this is one of the advantage of applicable of electromagnetic induction. Let's see, maybe all you have been aware one of the probably about transformers. Yeah friends, let's see, probably one of the greatest inventions of all time is known as transformers. So an transformer consists of two coils, primary coil and secondary coil. So an AC current from the primary coil moves quickly back and forth. We call it as the changing of magnetic flux in the secondary coil. If the secondary coil has more number of turns than the primary and voltage is increases and runs devices thus use high voltage, and we can call this as step-up transformer, and we can use this principle in reverse as well as to create a step-down transformer. So let's see how a transformer will be work. So see, working of transformer. When current in the primary coil changes as it is alternating, a change in magnetic field is produced. We all know this. The change in magnetic field gets associated to the secondary coil through the soft iron core. Hence, the magnetic flux linked with the secondary coil changes and induces EMF in the secondary coil. So this is what we know as learned about transformer. Let's see another application. Maybe all you have been aware of induction stove, which was we are presently using and always which you are going to use about induction stove for homemade cooking purpose. See, an AC current in a coil in stove top produces a change in magnetic field at the bottom of the metal pan. The changing in the metal magnetic field give rise to a current in the bottom of the metal pan. As the pan has resistance, current heats the pan. If the coil in the stove has low resistance, it doesn't get hot, but the pan does because it has resistance. So an insulator won't heat up upon this induction stove, because we know that insulators are the bad conductor of electricity. The flow of electricity, the flow of electric charges will not possible in insulators. So that's why insulators won't heat up in this induction stove. Let's see one of the probably greatest inventions about we all be aware, magnet leviation train. So magnetic leviation train or technology can be used in high speed trains. In high speed trains which are not typically traditional trains. In high speed trains like jet trains, bullet trains and electric power trains, and one among that magnetic leviation trains. So magnetic suspensions allows trains to accelerate to over 300 miles per hour and reduces maintenance by almost eliminating all parts or all moving parts. And from this figure we can see that these trains do not use traditional tracks or wheels. Only these trains attracts and use only magnetic forces to float on the track, and it will, because the friction is less between the tracks and the the train, that's why it will flow very speed. At this within 2 hours we can reach from Denver to Los Angeles within 2 hours only. So this is one of the greatest applicable of a magnetic levitation train. And these trains use a lot of power of electricity, which was typically 3 to 4 times a typical subway trains used. And several Japanese companies have been accommodated using this principle underlying in electromagnetic induction. So it was not accommodated in our country, so it was going to be implemented. So this is one of the basic and probably invention of electromagnetic induction, which was underlying in magnetic levitation trains. And see friends, maybe all you have been aware of bird's migration. Let me ask you one question: how birds will fly, and how they will fly from years later from place to place without determining their direction? How does it will happen? As we all know that the mysteries of the migratory patterns is one of the most privileged in the history of biology and technology and in science also. So there has been an idea that this electric magnetic induction will provide a clue to determine the direction from place to place where they have to reach. So let's see, how do birds fly when they migrate? When they migrate, they use a combination of methods such as visual cues, solar navigation, star navigation, polarized light, and magnetic fields. So using these, they will determine the direction, and there has been much evidence that magnetic field will provide or will play an important role in the navigation of birds migration. So not only this, there are a lot of applications are there. Presently we are using debit cards in big shopping malls. These insulators here, they will identify the correct or wrong persons, those who are crammed in those shopping malls. So this is about electromagnetic induction applications. So finally, I can conclude that Faraday's law of electromagnetic induction describes a very important electromagnetic concept, although its mathematical representations are very cryptic and very difficult to grasp. And these chances may have far-reaching ramifications that have so many ramifications from our lives, from the shining of the sun and the conventions of mobile communications and to electricity power our homes. And when Faraday published his experiment, some of the questions rises like that: what is the use of your invention? They asked that questions to Michael Faraday, but he given one question is that his reply was that, what is the use of newborn baby? Can you answer, friends? Yeah, what is the use of newborn baby? Can we answer such type of questions? No, it's difficult to answer such type of question. So the invention of electromagnetic induction is not only for the purpose of academic or practical only, also for theoretical utility also. Imagine in the world without there is no electricity, without no power, without no cell phones, without no personal computers, and without no trains. Just to think or just imagine a situation how the world would be. Oh my God, it's very difficult. It's very difficult to think of such type of situations. So we all have to appreciate the invention of this Michael Faraday's experiment, which was probably being used nowadays. So the pioneering experiments of Michael Faraday and Joseph Henry have directly led today's modern days generators and transformers in each and every fields. And if we want to develop more technological developments, as we all know that we are moving in a very fast generations and we are totally influenced by technology. So if you want to invite something more gadgets or devices, definitely the principle is electromagnetic induction is very, very essential and very useful to use this principle. But without, as we are seeing, if you want to electric current generator powers, each and every devices are working on the principle of this electromagnetic induction. Hope you friends, you all have been understand today's my topic, electromagnetic induction. So there is a students must and should know, and each and everybody should know about this concept, which are playing an important role in our future days and your future generations. So thank you for giving this a wonderful opportunity once again. And my special vote of thanks goes to Dr. R.S. Praveen Kumar sir, who bring us a marginalized students from grass to galaxy to providing such a great opportunity in front of you and in front of media, so in front of all. And special thanks goes to our college principal, T.V. Venkataraju sir garu, and vice principal of my college, C.H. Venkateswar sir garu, and sincerely I thankful my subject guide teachers, P. Srinivas sir garu and K. Sudhindra sir garu. Also, ICT Kondadar Muralidhar sir, who have present my presentation in a well direction. So thank you for media, and also my dear friends, once again thank you for giving this a wonderful opportunity.